before we get stuck into it as well, if you could all just, if you have any questions as we go, please feel free to ask them in the chat or the questions panel, and the team will get them collated, and we'll have some time for questions at the end, and anything we don't get through, we'll have a bit of a follow-up session off the back of it. So yeah, but thank you for joining everyone today. Quick overview of the agenda here. So some quick introductions, a few ways to operate, why autonomy matters, the barriers to automation, key considerations for automation, applications, DJI Enterprise automation, and then some of the kind of longer term, forward-looking pathway to autonomy and the end goal with Q&A at the end. So today you've got myself and Adam on the call. So Adam's webcam's out of action, I'm afraid, but you've got myself on display at the moment. So a quick introduction on myself. So I'm Elliot. I'm the Chief Remote Pilot here at Sphere. For those of you who haven't met before, thank you for joining us again today. Been with Sphere Drones for about 9 years now. It's been an exciting time. Really cool to see the industry change and grow, and the technology is just making life much easier, more effective, more efficient. Yeah, pretty exciting time. Adam, are you there? If you don't mind, just giving a quick introduction on yourself.
Yep, sure. So hi everyone, I'm Adam. I've got a background primarily around surveying, but I've been working with Sphere now for 2.5 to 3 years. Yeah, that's pretty well me. Thanks, El.
Thanks, Adam. So quick introduction to the business. For those of you who haven't seen this slide before, we were obviously founded back in 2014-15 with a headquarters in Alexandria. 2018, we established a hardware and engineering team. In 2019, there was the Internet of Things engineering team established, and the WA office opening. Software development team established back in 2020. We acquired Rise Above there in 22. BVLOS approval started coming in 2024 with BARS accreditation, opening a remote operations center. We've got that partnership there with Aptella for HubX. And then, of course, 2025 has seen the advent of our taking over of a manufacturing facility here in Seven Hills, and the manufacturing of Hub-T, which you can see in the banner behind me as well, very conveniently placed in the room when I arrived. But yeah, so it's been a pretty exciting journey so far. But I guess getting stuck into it. So 3 ways to operate. Of course, the primary one that you'll all likely be familiar with is the full manual pilot control. So the pilot, for example, going and conducting inspection tasks manually, or it might be something where there's an element of complexity to it that warrants having a person on the sticks. Things like water sampling and some other use cases are really good examples of where that manual control is really desirable. Sometimes it's also simpler, but in other ways, being able to automate things is can have quite a lot of advantages, as we'll discuss. So in terms of the concept of automated there, being able to pre-plan a mission and the pilot's monitoring it. So that can be conducted in a remote operations center, or it can be conducted, or an automated mission can be conducted in the field. So you plan your mission in the office or in the field, and then you execute, and the pilot's monitoring it to make sure that nothing goes wrong, and that the drone's behaving the way that it needs to behave, capturing the data that it's supposed to capture. And then there's the autonomy piece. So the autonomous state, where you've got a drone that can receive an input from an external source, or it can be pre-scheduled, and people aren't necessarily monitoring it. So that's certainly something that provides a lot of advantages from a flexibility perspective, being able to schedule things when you need and want them. Having the repetitive tasks able to be done on a schedule. So yeah, it's going to be a pretty exciting time over the next little while, seeing these sorts of things come into play. So in terms of why autonomy matters, so that workforce safety, so having people in hazardous environments like mining pits, etc., really can present that risk to human life. So being able to remove people from those hazardous environments and put them in a safer location is hugely advantageous. So if you're able to then take that one step further and have it be a little bit more autonomous, then you can save lives. So in terms of costs and time saving, so having to transit from one side of the site to the other, having to commute out into the field, set everything up, capture your data, and then get back to the office can take a lot of time, which of course equates to money. So if it is something where you're able to streamline that process, then you can potentially improve your cost savings, etc. From a scale and consistency perspective, having that autonomous capability means that you can repeat the data capture and have that be a standardized routine capture, where you do have that ability to make sure that you're getting the same high quality data every time without the variation of different people doing things in different ways. So being able to standardize that is really handy. And as you can see, that makes it a lot more reliable to compare apples with apples when you're reviewing that data set. And then data capture requirements. So modern projects demand high frequency, high resolution data, but manual operations can't keep up. So having that autonomy makes frequent, precise surveys practical. So kind of what we were talking about just before. So the barriers to automation, of course, in terms of the regulatory side of things, that's one of the considerations here is, at the moment, the appetite from industry and from the regulator is to have, a person at the helm monitoring and managing the aircraft in the air. So until it's something where that is more not loosely regulated, but until that's something where it's opened up a little bit more, it is going to be something where there is a requirement to have, at least one person monitoring a system. Eventually, improving that streamlining process, so it could be one pilot to multiple aircraft, or one pilot to many aircraft, can really smooth things out a little bit. But of course, you have to have the safety case there for that. So, and as you can see here, the safety protocols, so airspace deconfliction with both crewed aircraft and uncrewed traffic, are both important things to keep in mind. The ground risk management and redundancies are obviously critical to ensure that you can automate things safely, and having the right sorts of logics, etc., built into the systems that you're using. For a GNSS denied environments, it's a slightly separate kettle of fish, but worth mentioning here, of course. We have seen some really interesting advances in those underground environments, where there's the ability for drones with SLAM LiDAR systems to be able to go and autonomously explore these environments. So it makes a huge difference to the efficiencies and effectiveness and situational awareness, being able to gather data that you might not have been able to get previously because of signal limitations in that underground environment is can be game changing. Repeatability and reliability. So automated missions, they need to be predictable and stable, not just close enough. So having that ability to really prescribe exactly what the drone needs to do is really handy. Mission planning complexity. So in terms of the variable nature of sites, if you have a site that's constantly changing, you need to make sure that your data is being captured from the right spot, if that makes sense. So having a workflow to keep up with those changes on site are really important. And sorry, just circling back to the GNSS denied environment side of things. So if it's something where you are operating in the underground environment, there is an ability for some systems to collect that data, but there are some limitations, of course, with positional accuracy with those SLAM systems. So it's a double-edged sword with the GNSS denied environment side of things. The data validation and quality assurance. So automation is only useful if the captured data stands up to scrutiny. Quality assurance remains a critical step. So if you're not fact checking your data and you're not ensuring that the drone's capturing the right data in the right place, then you can end up with misinformation and making bad decisions. So a quick poll here for you all, if you don't mind. We've just got a question here for how would you describe your current drone operation? So that poll will pop up on the screen in just a moment. I'm just going to turn off my camera for a second. Beautiful. So we're seeing those questions starting to come through, those answers starting to come through. So fully manuated pilot flies every mission start to finish. I believe that that's supposed to be fully manual, but I like the unintentional homologation of words there to make a new one. Maybe that'll end up in the Oxford Dictionary Word of the Year. You never know. So thanks for those answers, team. We'll wait just a few more seconds for the final people to put their answers down. Alrighty, thank you everyone. And I've ticked the end poll. Key considerations for automation. So in terms of the regulations, as we spoke about before, making sure that you have the correct approvals for the task that you're doing. In terms of the appetite, like I said before, the appetite does tend to be more geared towards, one pilot to one drone at this stage, with the options, starting to become available with, one pilot to multiple systems, where they're both on the same site. They're often referred to as swarm operations. It depends a little bit on the nuance, but it is a separate approval to get that one to many operation. Flying further than visual line of sight. So if it's something where your pilot is not able to see and orient the drone with their eyes without the use of any additional optical devices, binoculars, cameras, etc., then it might be something where you need to look at an extended visual line of sight approval or a BVLOS approval there. So the eVLOS approval, just quickly, is an extended visual line of sight approval. That's not necessarily an area specific approval, whereas which means that you can fly potentially anywhere in the country within the scope of the approval from CASA, whereas a BVLOS approval is at this stage a site-specific approval, which means that if you want to go and operate in a different part of the country with a different air risk and ground risk, then you'll have to get a separate approval for that new location. So in terms of the automation side of things as well, the other capability to consider is the technology. Is the drone in use designed for automated operations? Most RPA that we see these days do have some level of automation. It's just a matter of whether that's useful and appropriate for the task at hand. So, if you've got a drone that is designed for internal inspections, for example, then it might be something that you don't have the ability to utilize that one in an outdoor environment where you've got high winds, etc. Similarly, if you've got an environment that's enormous to map, then it might be something where you need to look at a more capable system that has a better endurance or increased operating heights. Or it might be you need to look at something like multiple drones to cover that area. So things like obstacle detection as well, of course, are really important. Making sure that the drone is able to assist the pilot with maintaining separation from obstacles. Having an awareness of the environment that your drone is flying in is, of course, really important. We tend to tell people not to rely exclusively on those obstacle detection functionalities, because of the fact that they can potentially miss things like very fine obstacles, or if the sun's shining just so, then it could potentially obstruct the vision sensors or prevent the drone from being able to detect that obstacle and potentially cause a collision. That has been improving a lot over the years with the introduction of things like LiDAR for obstacle detection, etc. But again, it's something where it should be used as a supplementary thing rather than an exclusive buffer. Mission repetition, so the ability to repeat a task to a high degree of fidelity is quite important if you're looking to go and conduct a mission and the drone is not necessarily positionally accurate. It's finding itself in the wrong spot. Then you need to be able to have confidence that the drone's going to execute well. And then true autonomy, there is a difference between the drone going and conducting a task under monitoring of a pilot, but taking it that next step of, if you want to go and execute a mission without any pilot intervention, ignoring the legalities of it, you need to ensure that system is going to be reliable, land in the dock every time, You don't want to have a drone deployed in the middle of the desert and have it land, outside the dock, too frequently. It can be a bit of a pain. Safety. So of course, safety takes up quite a big section of this slide for good reason. Safety is always paramount. Air and ground risks, so having an awareness of what's happening around you, planning for standard environmental scenarios and interaction with infrastructure, other site stakeholders, whether they're automated or non. That's one of the things where you need to be aware of who else might be operating on site. Keeping that separation is really important. A plan for when the drone goes off course. So if you have a situation where the return to home landing position is set before takeoff, then you can be confident that it's going to land in a safe location. If that wasn't available, having an idea of where that drone will land, with the new dock systems, you do have that ability to set an alternate landing area. The fail-safe option of a parachute, for example, they may be required in some scenarios where you do have those, increased risk profiles. That is something that is, starting to become more commonplace, which is exciting to see. And then geofencing as well. So in the event that, the drone accidentally, maybe the pilot is, flying somewhere and they forget about the fact that there's a place that they're not supposed to go, having that geofencing capability can really help improve the safety of operations there. Environmental conditions are of course really important. Having that ability to leverage real-time and or forecasted information. So we've seen that been introduced in some of the latest dock situations, which is great. In terms of the rainfall, of course, the quality of your data might not necessarily be that great if you are flying in rain, ignoring the legal considerations there. The other thing is that while drones do have ingress protection ratings, they're starting to come with those, which is great. It's something where one needs to consider whether it's necessary or appropriate to go and fly in that inclement weather. One does, of course, need to maintain separation from crewed aircraft operators as well, and stick to the CASA regulations as well. So in terms of considerations for automation there, as I've said before, so having that one to multiple capability will be really advantageous. While it's not really practical to have one person flying multiple RPA at a time, it is something where autonomy does bring that capability to have multiple aircraft managed effectively. It does require careful planning, execution, and protocols to ensure that you can do it safely and effectively, and there's no risk of people making erroneous decisions. You need to ensure that they're all configured correctly, and there's no conflict in the event of an emergency, and those fail-safes all need to be planned appropriately. So, and then as I've said there as well, having that additional approval in place is really important too. So software as well, of course. So mission-specific planning software is going to make a huge difference to the experience and the reliability of these processes, and the data that is delivered as part of those operations. In terms of the native software, they have become very capable with some really neat automations available. Making sure that you have the right software for the right tasks is also really important. If you're looking to execute really complex tasks, that's something where, you want to have the right software for the job. Post-processing software, is it capable of outputting the data that you're looking for? In terms of the photogrammetry, that's something that's quite familiar with a lot of people. Having that ability to generate the right sort of insights, and taking it that next step. It's not necessarily about the capture or the processing. It's about what your deliverable is at the end. That's the important part of it. And so the post-processing software is that necessary part of the automation. So current applications for automation. So in terms of the mining, you've got stockpile measurement and monitoring, rehabilitation and site monitoring, stope and overhang inspections. So there's been some interesting improvements there in the automation space underground. Utilities, power line inspections, sewer leak detection, water treatment plant monitoring, Within infrastructure, you've got road analysis, bridge crack detection, tunnel inspections. So it just comes down to the use case, the drone, the software, and making sure that the fit is there. So in terms of automation with DJI Enterprise hardware, you can see here we've got automated terrain following and mapping, high accuracy photogrammetry, environmental monitoring, advanced LiDAR scanning and modeling, and multi-sensor detection and tracking. So some of these capabilities that have come out with the latest DJI generation of DJI enterprise solutions is really impressive to see. Having that ability to prefabricate your flight plans and basically execute on site without having to spend ages in the field planning out missions, etc., can be hugely advantageous in terms of the workflow in field. The pilots would then ensure that the flight plan does indeed align with the real world environments that they're seeing on site. But as you can see, with the docks being able to be deployed in site, it does mean that pilot doesn't necessarily have to be going out into the field to execute those missions. So yeah, it just depends on what your task is. There's a variety of different solutions to tick the box there for you. So in terms of some of the software here, you can see we've got DJI Pilot 2, which is of course on that remote controller there on the right hand side. Being able to execute those pre-planned missions. You can also do things like recording a mission, so you can go and create a capture yourself and then save that flight plan and go and re-execute. So having that ability to automate things in that fashion based off a manual capture in the first instance is a really neat workflow. DJI Flight Hub, so a cloud-based mission scheduling there. For those of you who aren't familiar with it, it does have the ability to be utilized for non-dock solutions as well. But one of the biggest use cases for that, of course, is the dock-based deployment. Having that 2 and 3D modeling capability inside Terra is, of course, really handy. And then DJI has released that DJI Modify software for further manipulation, modification, and generation of data that you've captured with all the DJI products there. So, and then of course, outside the DJI ecosystem, being able to utilize those other solutions to get it into the formats and coordinate reference systems, etc., that you might need for your site-specific requirements. So a quick poll here for everyone again, if you don't mind. So what's your biggest blocker to scaling autonomous drone workflows? So I'll just leave this one up for a little bit, and we'll get some input from you all on what we're seeing. Alrighty, thank you everyone. So it looks like the big ticket items here are regulatory hurdles or setup time or system complexity. So thank you for the insights on that one, team. Alrighty. So the pathway. So in terms of the pathway to autonomy, taking an existing and repetitive flight route, start creating an automated mission for it. So that's kind of what I was talking about before with regards to the ability to go and capture data sets manually in the field or in a semi-autonomous way, and then being able to rinse and repeat that same task is one of the best first steps that you can take, and that doesn't necessarily require any additional approvals, etc. But yeah, a system like the DJI Flight Hub can allow you to really quickly and easily share that kind of flight planning capability there. So once you're comfortable and happy with the performance, you can expand to other repetitive routes. So ensuring that you're not just running before you've started walking, if that makes sense. So being able to go and test the capability in one particular part of the site, and then go and execute and expand and roll that out once you've established that the workflow is working, that the data quality is good, and it's what you need. Making sure that it's behaving in a safe way. Things like terrain following, etc., could potentially play funny business with your execution of your mission. So making sure that you've considered all of those sorts of things is always, of course, really important. And so, yeah, as you go, you're picking up new things and learning more about creating the optimal routes and the quirks of how it works. So ensuring that once you've got the basic flight planning done, you can then go and improve the efficiency and effectiveness. Streamline things, get better quality data. Maybe you go and capture a digital model of the environment and feed that back into the system, and then you're flying off a real world model instead of off the satellite imagery that might be a little bit antiquated. And then eventually, being able to move into the drone in a box sort of environment, where you do have that ability to kind of remove the need to physically travel to site. It might be something where you're able to, you could potentially start by having a drone in a box deployed on site under visual line of sight or extended visual line of sight, and then transition across to extended visual line of sight with a remote operations center and or a BVLOS operation. And so, of course, the autonomy end goal is to ensure that you have that ability to execute fully remote, repeatable BVLOS missions without the need for on-site pilots. So it's something where often we do. One of the big advantages of that facet of this equation is that you do have that ability to then make sure that the people who are on site have the ability to focus on the important things that they need to focus on, rather than potentially capturing data sets that are a little bit more easily capturable via the remote deployment side of things. Always on data capture, so having that ability to capture reliable scheduled missions with consistent insights coming into your inbox. Seamless integration, so of course you can see our HubX system on the screen here. So HubX and HubT with the remote operations center working as the backbone of autonomous operations. Scalable safety and efficiency, so again making sure that the people who are on the ground have to be there, and the people who don't need to be running around amongst haul trucks keeping themselves in a safe location, but also ensuring that the data quality and frequency is satisfying that site requirement. So how Sphere can support your autonomy journey. So we are able to provide that support for training, for BVLOS approvals, etc. If it is something where you wanted to have a HubX or a HubT deployed, that's something where we're able to support you there with an end-to-end solution. Managed services, so if it's something where you're wanting to get started, then that's certainly something we can help you with. And then of course we do have our own remote operations center with an operating certificate, etc. So yeah, we are able to help support with that side of things. So that's the end of the presentation section for the moment. So I'll just have a quick look at the questions that we have got coming through. So we've got a question here from Brendan. Thanks for sending that one through, Brendan. So in terms of a completely enclosed environment, such as an underground environment, does CASA still care? Look, technically at the end of the day, a drone is technically something that would fall under CASA's remit. I believe that if you're operating a drone in and around, in a work environment, obviously in the underground environment, there are obviously a lot of regulations and safe work processes and procedures that do apply and do keep people safe in that underground environment. The approach that we've taken is getting the approvals and all that sort of stuff in place, but it is something where I would be getting the approvals with CASA is my recommendation there. There's obviously a little bit of work involved in getting that. It's become a lot easier than it used to be, but I think the other side of that coin is also ensuring that your team are competent and capable of operating the technology in a safe way and an effective way, and making sure that they have the appropriate training, etc.
Sorry,
And-
uh, just want to jump in here on this one as
yeah,
well.
thanks, Adam.
I noticed one of the key words that Brendan has thrown in there is completely enclosed. I think that's an interesting one, the way that you worded it there. Um, Obviously, if a space is not completely enclosed, i.e., the drone could possibly escape the space, you are then, there is potential for the drone to enter controlled airspace and so on. And so that becomes, obviously CASA's space. But when we're in a completely enclosed environment, yeah, as Al said, that's kind of a gray area, um, because yeah, you're not in controlled airspace, or even uncontrolled airspace for that matter, because you're underground. Um, uh, but yeah, that I just wanted to point out that completely enclosed space does change things, and
Yeah,
we
that's
can put mitigations in place to ensure that it's enclosed.
Yeah. No, that's a great point. Thanks for that, Adam. And yeah, look, I guess at the end of the day, drones are technically an aviation activity. It's a bit of a weird gray area given that crewed aircraft can't really fly in an underground environment, so the regulations don't necessarily apply to those in an enclosed environment. But effectively, they are still technically an aviation activity, even if that aviation activity is being conducted underground. So I think that's the caveat. But look, we can maybe leave that one there for the moment, and if there's any further questions on that one, we can certainly circle back. In terms of another question here around the autonomy, so has CASA approved a true autonomous operation yet? There's a bit of nuance in the definition of autonomy, and I'm glad that you asked that question because it does warrant a bit of an unpacking, if that makes sense. The concept of autonomy implies that there's a couple of different aspects to it. So if you've got a situation where a person isn't able to intervene, then that is where that would become autonomous. So if you've got someone who's pre-planning a flight, then technically a person is involved in that generation of a mission, if that makes sense. So you can streamline the workflow quite substantially, and then it just comes down to whether the drone is able to be, if control is able to be taken off that drone and intervened in the event that you need to send the drone to return to home, or have it land if you've got an emergency on site or something like that. So in terms of whether CASA has approved one, I'd have to double check. I couldn't quite say. I believe that there would be some operations that have been conducted where the drone goes outside that control, and so my suspicion is probably they have. But whether it's the true autonomy of a drone in a box that's flying 24/7 and making its own decisions around whether it flies or doesn't fly, etc., or whether it takes evasive action, etc., is a slightly separate conversation. But thanks for that question. What are the legalities around using drones near power lines? That's a great question, Paul. Look, I would actually have to defer to the energy providers to weigh in on that one. As far as I'm aware, the airspace isn't necessarily owned by the power line companies, etc. But it is something where one would need to use, appropriate levels of caution. If there's any doubt, I would be checking with the power companies. But my understanding is that as long as you're, acting in a safe and appropriate way, and with the appropriate trainings and risk assessments, etc., being completed, then yeah, I wouldn't expect there to be legalities preventing you from doing power line inspections, for example. But yeah. And interference, yes. So in terms of interference to the drone system, so if it is something where the drone is operating in proximity to power lines, there is of course a possibility with some power line systems that they could potentially be putting out some interference, which might impact on the drone stability, etc. So if it is something where you are operating in proximity to power lines, one does need to be very careful, making sure that they're potentially using things like, RTK to provide that extra resistance to interference. Sometimes it's not necessarily just the power lines. It's possible for the drone to have magnetic interference from metal in the ground. Adam actually had a situation where a drone had interference with the compass on launch, and the drone actually decided to misbehave and fly away a little bit. But he was very quick to respond and manually took over and put it into ADI mode and brought the drone back and landed it safely. So tip of the hat to Mr. Adam for quick thinking and good familiarity with the system. And we've got some other questions here as well. Bear with me for a second. Also, please feel free, everyone, if you do have more questions that you want to put through in the chat, do feel free to shoot them through. Bear with me for a second. I'm just checking my other document that has some other questions in it. Can DJI dock systems really operate in harsh Australian conditions like high heat or dust? That's a great question. In terms of the maintenance of the docks, it is something where you do need to be mindful of the maintenance considerations. Operating in those high stress environments does, potentially result in more wear and tear on the system. So you do need to make sure that you're taking good care of it and maintaining it at more frequent intervals if you are in those harsher environments. But the new ingress protection ratings and things on drones have become quite robust. So they have become a lot more capable. I believe the M4, the Matrice 4D for the Dock 3, I think that's something like minus 20 to plus 50 degrees Celsius. Pretty capable systems these days. So is one pilot managing multiple drones a realistic option now or still a future thing? Another good question. So in terms of the ability to control multiple drones, it is certainly a possibility at the moment. For those of you who've used the Phantom 4 RTKs or the Agras drones, they do have the ability to utilize a swarm sort of capability where you link them up and you set their own return to home locations, and you can go and cover a larger area with one pilot with one remote controller. But of course, to do that, you do need to ensure that you have the appropriate approvals and permissions and everything in place. And of course, having the appropriate procedures and emergency response plans and all that sort of stuff devised so that you can respond appropriately and don't get confused about which drone you're controlling. What else have we got here? I think that's the bulk of it for the moment. What we might do is if there's any other questions that anyone does have that I haven't gotten to in the call, we'll certainly follow up off the back of the webinar. But really appreciate everyone joining. If you've got any thoughts, comments, feedback, we're always really happy to hear from you guys. But yeah, thank you so much for joining us today. If there's anything else you need, our details are just on the screen there. Thank you so much for joining and paying attention and all your great questions.